My background is I've worked with Anglo in Zimbabwe for almost 25 years, initially as an engineer in their mining companies there. I've also been involved a lot in project work with them and in operations management. My colleague Manuel worked for many years for a Greco, power rental company, and so is well versed in that side of the industry. And I thought you might be interested this afternoon in hearing about our experience trying to find a power solution for a junior mining company which would reduce our power costs. Our company, Shanta operates in Tanzania. It's a very remote mine, about 900 kilometers southwest of Dar es Salaam, from where we have to road truck all of our fuel. We mill about 50,000 tons a month, produce about 80,000 ounces of gold a year, and currently our demand is 2,500 kilowatts. We've been mining as an open cast operation. We started at the end of 2012 with a 5-year life of mine. The additional drilling exploration that we've done means that as I stand here, we're hopeful of having a 7-year life of mine from now, and we're doing a feasibility study at the moment which involves going underground with a big increase in the power demand, which in fact will double our current demand. So that's the background, I put this slide up just to demonstrate, and it's been amply mentioned in the previous presentations, that there is a lot said about renewables. There's a lot said about the problems with the energy shortages and difficulties that we face in Africa. I don't need to say anything more about it, I don't think now, because they've been amply covered by the previous speakers. I'd like to pass this over to Manuel now, just to run you through this slide.
Good afternoon, everybody. Ian, thank you for your introduction. Thanks also to Adrian for inviting us to come and speak. We'll come on to my involvement later on in the project, but I was, in my involvement working with a supplier of power, I found it was always very linear. So you never covered many of the options that were covered, that are required when you build a mine in a remote location. And just want to illustrate this point, here's my miner, and he's at his coal mine, and he's really struggling because he's in the middle of nowhere and he's in Tanzania. And all of a sudden, because there's no reliable grid, he's hit with a 40% cost of production, which is just his cost of electricity. Which in Ian's case means that 40% of 80,000 ounces goes to paying for his power. And Shanta approached us and said, this is too expensive, can you reduce it for us? And you've got this guy here on the other side, who's a bit of a sinister, dark character, who's also known as the investor. And what happens is the mine, you see, goes to the investor and says, I need $200 million to build this mine. And the first time round, he's quite lucky because it was in 2007. The second time round, he goes back in 2012 and says, please, can you give me some more money? Because now I want to go underground. And the investor says, yeah, sure. If you cut your margins by 40%, I'll give you another $100 million. And that's pretty much where we sort of entered. I'm just trying to illustrate the scenario. It's not the exact numbers, but it's just trying to illustrate the scenario. So the investor then says, we'll give you some more money, but you've got to show me that you're showing a 30% reduction in cost. And then you've got this big green eye down here, which is the ever-watching green eye, and ever-growing green eye, let's say, which everyone is aware of, and we're all talking about carbon footprint here. So that's a big influence on mining, and then you've got the community development aspect, which we tend to in mining we tend to sweep it under the carpet. So what we actually did was to try and focus on the power reduction, the power cost at the mine, which in Tanzania, as we were told earlier on by Nick Showman, if he's still around, I don't know, is very, very different to South Africa and actually a whole lot more expensive. So that's kind of setting the scene for the problematic of your remote mine, which is very different to your grid mine. And I'm just going to hand back to Ian now for the next slide.
Thanks, Manuel. So factors driving our power plant assessment. Again, quite a lot of this has already been covered. One of the things I needed, not being completely au fait with all of these aspects of power generation when we set out on this, was some independent advice, which wasn't prejudiced towards any particular type of power generation. We needed to assess the life cycle cost of producing the power, and I do find that speaking to different people, one can get all sorts of costs per kilowatt hour for generating power, which are often very different because people take different things into account when they're generating them. Obviously, one needs to look at reducing emissions. That is an important factor for mine operations, and therefore adding renewables, which always helps in that regard, but only when they're financially viable. And the point's been made amply before that, certainly in our case, as a remote off-grid mine, our first priority is to have reliable power for the mine 24/7. And once we've achieved that, then we can start looking at, for example, solar PV as an addition, if it's only available during daylight hours, because we felt that storage of solar power has been not being financially viable for us. And then one has to challenge all of the accepted norms and look at everything to make sure you're making the correct recommendations. And I would emphasize that every project, every mine is different with their own peculiarities. We don't have a grid supply. We're out in the middle of nowhere. The logistics are very different. And then just underneath is a bit of another slide from the recent power study that was done, just emphasizing how far we've got to go with power development in Southern Africa, and the fact that solar or renewables can provide a significant portion of that. So looking at the cost of power, if I could just hand you back to Manuel just to run you through this slide.
Thank you, Ian. It's actually quite expensive, but I'm telling an audience of people that know that. But having heard the presentation this morning, it's substantially more expensive than Eskom power, be it reliable or not. And the easy route or the path of no resistance is to say, I'm going to put in a diesel generated system because it's readily available, because the capex on the generators is cheap, because the requirement for the support infrastructure is relatively minimal, and to be honest with you, 763 kilometers from Dar es Salaam, it's actually pretty much the only reliable solution you're going to have. Which is how it was originally set up in 2012. But you then start and it gets a bit nerdy here, so I apologize for the technicalities, but you start looking at generators and you start realizing that generators are actually not that power efficient. In fact, they're only 32% efficient. And every single megawatt of power that you put on the ground uses around about, there or thereabouts, 270 litres per megawatt per hour, which you multiply it by 5, and it comes quite a lot. Or if you multiply it by, there was a gentleman this morning, 600, well, you know, it's an unimaginable number. Or you go to ESCOM and you say, well, how much power do you need? Well, we need 1,000 megawatts. 1,000 times 270 times 24 times 7 is a big number. So, you know, it is actually a real consideration to look at these numbers. You know, the previous speaker said, you know, it's about really analysing the capex and the opex before you do the project, and that's so important in this case. So let's, you know, I mean, this is actually a number that's now based on the current price of diesel in Africa. So we say it's $1 a litre, of which 68% is thrown away because you're only 32% efficient. And then you end up with this. The typical power plant for a small gold mine with a processing plant and ball mills running continuously at 6 megawatts is 39,000 litres a day, which is 273,000 litres a week, which is at $1 a litre, $14 million a year. And you know, this is small fry comparison to what we're talking about today. Compared to this, subsidised power grid in Tanzania is 16 cents, but with frequent outages, instability, limited distribution, and a previous speaker from Hatch, he said, for every 100 milliseconds that you're out, you have a 4-hour outage. And it is a 4-hour outage because when your ball mill's full and your mills are there, and it will take you 4 hours to restart that mill. So, cut to the chase, your diesel fuel cost is 27 cents a kilowatt hour, plus your rental, which is 8 cents, gives you a cost of 35 cents per kilowatt hour just to run the power plant. And that's the real cost, and that's actually a reduced cost, because when we started this project, that 35 was 44 based on the old oil price. So, and let's see where we went. Ian.
Okay, so I've already run through this briefly. New Luika is our flagship project for Shanta. The energy cost in 2013 represented over 30% of our operating costs. And the fuel costs represented 80% of the energy costs. So we went to MCD to do a desktop study just to look at the options that we might have to reduce our energy costs. The desktop study looked at the cost and availability of fuels and the different technologies that were available to us. We looked at the whole gamut of things. And we're obviously particularly concerned about the economic impact and the logistics as part of that study. Manuel, do you just want to run through this?
You can stay here, it's
okay.
All right here.
Sorry, so we basically asked ourselves why, what, and how, Manuel?
Yeah, and what's interesting about this, and we won't talk to all of it, but what's interesting about it is that the key driver is the fuel. It's actually not, you know, you can call yourselves an energy consultancy and you can do energy consultancy, but actually it's about the fuel. You know, you're 700 kilometers from the middle of nowhere. What can you actually get there? You know, and based on what you decide about what the fuel is and what the logistics of getting that fuel to the mine site are, is what will predetermine how you actually manage the power at the mine. And in this particular case, we ended up with, so you have ball mills, which means you need inertia. And there's pretty much only diesel, HFO, and hydroelectric that will give you the inertia that you need in order to be able to start the ball mills economically. There are other options, but they don't just, the economics of it just doesn't stack up. And of course, solar. So we then looked at the configuration and how you put it together, the variable costs, and very similarly to the gentleman from the war rooms We do a real analysis of how all those things can come together and actually make a power plant work. And finally, we looked at rental versus procurement, and it's something that I haven't heard mentioned at all here, from a rental background, and I know friends from Caterpillar are here. But rental is a serious option, especially when you're capital constrained. And the big advantage that it does offer is that you have a turnkey plant that's serviced and managed by the provider, very similar to an IPP, and you never get to the capital cost of it. So we looked at all these factors, and then we went back to Shanta and said, based on what we know, based on the fuel, based on the technologies that you've presented me with, these are the options that we actually have.
Yeah, thanks, Manuel. So the points being made much earlier today about how in the larger mining groups we look at things very closely before we make any decisions, and that power supply companies have to attune themselves to the need to address that sort of detailed investigation. The sequence of events in that study that was set out by Hatch previously are, I believe, what you have to go through on every investigation. And for the very small user, if you're not keen to pay $250 an hour to Hatch, you need to try and find a way of doing it a little less cheaply. Just to summarize, this was just to summarize where we were. We're in a very remote area of Tanzania. We were offered 4 megawatts of intermittent grid power from TANESCO at a location 5 kilometers from the mine. The mine was built with a 5 megawatt rented island diesel power plant. Our consumption's about 24,000 megawatt hours per annum, which is equivalent to 2.5 megawatts demand at the moment, and that will more or less double as we go underground. We're in a unique situation, so no generalized solution is available off the shelf, as it were, and that requires unbiased and a comprehensive understanding and study of the cost and suitability of the alternative solutions that are available from the myriad of options punted by the various enthusiastic salesmen. And the feasibility study evaluated all of these options in order that we could establish the true life cycle cost of the energy. The investment decision is easier if oil prices are stable. Some discussions have been had today about how do you formulate an investment strategy if you don't know what the cost of energy is going to be in the future. It's de-risked only from a detailed assessment of the mine demand characteristics, unbiased advice, visits to look at what other people are doing, and the study of the literature, and the commercially available mature technologies. One generally doesn't want to be a guinea pig. And from all of that, you hope to gain a proper understanding of why each technology was chosen, and helps you to discern what's appropriate for your unique situation. The renewable energy storage cost is usually prohibitive, whether it's battery or the other methods that have been talked about earlier today. So the island power plant must provide 100% of the maximum demand, and renewable energy costs must compete with the variable cost of the energy, which is usually the fuel cost. We originally had 6 0.9 megawatt diesel gen sets rented from Aggreko, in fact, a very good company. It does what it says on the tin, very reliable. They agreed to convert 4 of them to heavy fuel oil. They're still the high-speed Cummins diesels, but running on HFO with the pre-treatment facility that's needed to condition that fuel. We also added a solar PV plant. It's only 65 kilowatts, but it's fully scalable, and it enabled us to monitor in real time the daily production. And with the intention of helping us to evaluate whether we could justify a much larger solar plant as an addition to our 100% base load generation plant. So I think we became the first hybrid HFO and solar PV plant. The HFO at the moment we're paying 66 cents a litre compared to diesel at 97. So the conversion from diesel to HFO with the 4 gen sets enabled us to save 32% of the fuel cost, which, as I said earlier, was 80% of the energy cost, and therefore very significant. We're reviewing the option at the moment to look at up to 5 megawatts of solar, providing that will give us savings over our 5-year life of mine. The solar plant we have is being supplied by Redavia. It's very simple, no foundations, just needs a clear level area. 3 months, they offered us quite an interesting package, a 3-month trial period prior to acceptance or return, a 2-year PPA contract, inclusive of supplier operation and maintenance, which is quite a short time period if one wants to look at solar PV. They integrated it fully with our HFO plant. It's fully synchronized. The power is fed in from the solar panels as the sun comes up and then fades away as the sun goes down. It's been very reliable, and it's fully scalable if we want to uprate it in future. And the graph just illustrates the power that's been generated and the carbon emissions that we've saved. And in spite of the fact that the carbon emissions, because of the very small scale of the plant, have been relatively small, nevertheless, they've been of great interest to the directors and the market, who take a very favourable view of all attempts that companies make to green up. The alternative energy that we've looked at, our baseload technology is diesel moving to HFO, which will reduce our life cycle cost to 26 cents a kilowatt hour. Listening to the discussions today, it's quite remarkable for me to hear the reliance that people still place on the grid here, in spite of the problems that you're having with Eskom. As has been mentioned already, our grid supply in Tanzania is very unreliable, and the quality of the power is very poor. So when you've no choice other than to generate your own power, of course you take a completely different view as to how you should or what you should do than if you are in a more developed country with reliable grid power. We're very interested in looking at waste heat recovery to save 5 or 10% of our fuel, which would be a big number for us. And we're also looking at the possibility of using Tenesco power, such as is available. It's only 4 megawatts. But we acknowledge that we'd have to look at conditioning that to avoid the voltage spikes and other problems and outages that occur on a daily basis with it, and having the ability to ride through any sudden instantaneous drops of that 4 megawatt supply. We've looked at hydroelectric. We have a river that flows near the mine over a 130 metre high escarpment. It only flows for 8 months of the year though. So nevertheless, we do have a hydroelectric supplier who's still interested in talking to us about supplying PPA agreement for the 8 months of the year. The only problem with PPA agreements are that they tend to lock you in for very long time periods of taking all of the energy that they produce. And if, as has been said earlier, that many mines have a 5 to 7 year life of mine, it's very difficult for PPA people people to install the plant and recover their capital over 5 years without causing the unit costs to be, or charges or prices for the power to be relatively high. I believe that with solar power we could, if we were to install some panels ourselves, we could get down as low as 15. I think with a PPA we'd probably be looking somewhere around 21 cents a kilowatt hour. We've evaluated the installation of a heavy fuel oil generator plant compared to our present rented plant, on the basis that the heavy fuel oil plant would be a turnkey plant, maintained and operated by the supplier. And as you can see from this graph, in the first 2 years, in the first year we pay virtually the same because we still have to run the existing plant whilst we build and commission the new one. In the second year we pay quite a bit more for the new plant because we're having to repay the cost of the plant. But from then onwards, because of the fuel savings, our annual cost in green is much lower than for our existing plant. And so this looks like a very attractive investment for us, providing we can finance it. And we're in the final throes of completing the feasibility study this quarter, so we shall see what transpires. Just a couple of slides to show with our rental option. The fixed costs are about 19% of the total cost of the energy, whereas with the proposed plant, although on a life cycle cost basis, the fixed costs go up to 33% because we're having to pay for the plant. Then, of course, then the variable costs are much less, and it's that variable cost that the solar PV power would have to compete with. We looked at the pros and cons of the different technologies. I won't go through those now, it's all rather detailed, but they're there in the slides if you want to have a look at them. And that's it. So if anyone has any questions, we'd be happy to answer them. Thank you.